Hi everyone, we are reviewing the problems in Chapter 6, Steady-State AC Analysis. First, we look at this example. In this example, it has an AC voltage source, an inductor, a resistor, and a capacitor. And it asks you to find VCT, which is the voltage across the capacitor through, and also the phasor current through each element, and construct a phasor diagram showing the currents and the source voltage. So the first thing we have to do is we need to convert everything in the circuit into its phasor representation and impedance. So first we look at this voltage source, and because phasor is defined from cosine. So the first thing we need to do is to convert sine to cosine. So we talk about this. If you want to convert sine to cosine, you need to resort to this plot. So in the plot, the pointing to the right is cosine theta, and sine theta point the direction of sine theta pointing down, and the opposite of it is minus cosine theta. The opposite of sine is minus sine. Okay, and because we want to convert sine to cosine, so on this plot, we start from cosine, and the direction of the angle is clockwise, so it's minus 90 degree. So we have a relationship here, which is cosine theta minus 90 degree equals sine theta. Because we want to convert to cosine, we start from cosine. So if we make that theta equals 1000t, so we have cosine 1000t minus 90 degree equals sine 1000t. Okay, so we convert sine 1000t to cosine 1000t minus 90 degree, which is our VST, which means VST is 10 times cosine 1000t minus 19 degree, and the unit is volt. So VS, the phasor of the voltage source is 10, its amplitude, and degree is minus 90 degree. Okay, so we write it here, VS is 10 degrees minus 90 degree. And then we need to convert resistors, inductor, and capacitor to impedance. So the impedance of a resistor is just a real number, so we don't need to do anything. And to convert the inductor to its impedance ZL, we resort to a formula J omega L. Okay, so J omega is 1000 and its inductance is 0.1. So we have 100 J. The unit is omega. Okay, so the unit of Vs is V. And then we're converting the capacitance into impedance. So it's 1 over J omega C equals minus J omega C, and which equals minus J 1000, and C is 10 times the power of minus 6, and which is minus J 100. The unit is omega. So we're able to convert, we just write it here. ZL is 100J and ZC is minus J 100. Okay. So what do we need to find? We need to find the voltage across the capacitor, which is VC here. And so what I'm going to do is I want to find the total impedance first. Okay, so the total impedance. So first of all, we make R and C in parallel. So we calculate, we say it's ZRC equals ZR in parallel with ZC. Okay, so to calculate the parallel of impedance is similar, or you can say is identical to the calculation of two resistors in parallel. So we have ZR times ZC and divided by ZR plus ZC. Okay, so we can calculate it. So it's 100 multiplied by minus 100J, or minus J 100, and 100 minus J 100. And to the division of impedance, it's better to convert the phasor into its polar form. Okay, so if we convert the numerator into the polar form, it has 10, the amplitude is 10 to the power of 4, and because it's minus J, the angle is minus 90 degrees. Okay, and to convert the denominator to its polar form, because let's look at which quadrant it locates. So the real part is positive, and the imaginary part is negative, which means it falls here, right? And so because the amplitude is both 100, so it's the real and imaginary value are both 100, so its amplitude is 100 times square root of 2. And because it's on the fourth quadrant, so it just minus 45 degree, right? So degree is minus 45 degree. So we're able to calculate, so the amplitude is 10 to the power of 4 divided by 100 square root of 2. So its amplitude is 70.71, and its angle is minus 90 minus 45 degree, which is 70.71, and the angle is minus 45 degree, and the unit is ohm. Okay, so we have this. We combine. We figure out an equivalent resistance for resistors and capacitors in parallel. And the problem asks us to calculate the voltage across this capacitor, which means the voltage across ZRC. Okay, so by voltage division rule, so we know VC should be Vs, the voltage source, times voltage division rule. So we have ZRC in the numerator and ZL plus ZRC in the denominator. So we plug in the numbers. It's 10. We just convert the voltage source into its phasor. 10, 90 minus 90 degree times ZRC. We just calculate the ZRC. It's 70.71 degree minus 45. And then on the denominator, we have ZL. ZL is 100J, which means it's amplitude is 100. Angle is positive 90 degree. And oh, actually, we don't need to convert because for the summation of this impedance, we need to convert impedance into its rectangular form. So we just have ZL is 100J. It's a rectangular form already, and plus we need to convert this into its rectangular form. So it's 70.71 cosine minus 45 degree plus J 70.71 sine minus 45 degree. Okay, so this is our ZRC. And the answer actually is okay. The answer actually is, so I did the calculation on my own, but you are encouraged to double check. So I write it down. So we have 10 degree minus 90 degree and times 70.71. This is minus 45 degree. And then we have 50 plus 50J in the denominator. And because we are doing the phasor division, so we need to convert this value into its phasor, which is 50 times square root of 2. And because they are the real number is positive and the imaginary number is also positive, so it is in the first quadrant, so it's positive 45 degree. Okay, and so we can calculate. So we have 10 times 70.71 divided by 50 times square root of 2, and the angle is minus 90 degree minus 45 degree minus 45 degree, which is the amplitude is 10. The angle is minus 180 degree, and the unit is volt. Okay, and because this example asks you to write down VCT, so we can write VCT. Can write VCT equals 10 cosine. Omega is still 1,000. T minus 180 degree. The unit is volt. So this is the first answer, find VCT. And secondly, it asks us to find the phasor current through each element. The phasor current. So this is what I'm going to do. um, I'm going to calculate the total impedance. Actually, we have total impedance, which is this. This is total impedance, right? Because we put capacitor and resistor in parallel to find ZRC and ZRC in series of ZL. So this is Z total. So we already have the total impedance, I'm able to calculate the current I flow into the inductor. Okay, and so I got the current flowing into the inductor, and to calculate, so this is suppose this is I want to use different color. So let me change color. So we need to find out this. This is IL. No, I define this as I. Sorry. So this is I. I use phasor, and I also want to find IR, and also IC. Okay. So to find out I'm able to, so I should be what? VS divided by Z total, right? Okay. So um, let us, and also how to find out IR and IC. So since there are several ways to calculate, first, once you find out I, you can apply current division rule. But since we have VC, so we should have, so here, IR should be just by Ohm's law, should be the phasor of VC divided by R, right? Because R is a real number. Okay. And IC, IC should be VC divided by ZC, right? Because once we convert everything into impedance, and then we are able to apply Ohm's law to phasor and impedance. Okay, so that's what I do it because, and the reason is I already have VC. Okay, if I don't have VC, I may resort to current division rule. Okay, so first let's calculate uh, I, the current flowing through the inductor. Okay, let's change the current. All right, so we want to calculate I. So let me redraw it again. This is I. This is sorry. Okay, whoops. This is IR. This is IR, and this is IC. Okay, so I equals Vs divided by the total impedance, which is 10 to the power of minus 90 divided by 50 square roots, 50 times square root of 2, angle is 45 degree, and its value is 0.1414, angle is minus 135 degree, and the unit is amp. Okay, so IR is VC because this is VC. VC is the voltage across the capacitor, also the voltage across the resistor, divided by ZR, which is 10 to the power of minus 180 degree, divided by 100, a real number, but you can write degree 0 or not. So it's 0.1 and degree is minus 180 amp. Hey, and what happens to IC? So IC equals VC divided by ZC. Okay, and so which is 10 to the power to the 10 angle is minus 180 degree, and ZC is minus 100J. We need to convert it to phasors. Polar form is 10 angle minus 180, and this is 100 minus 90 degree, which is 0.1 angle is minus 90 degree M. And one thing we can notice is what? Is one thing we can notice is KCL need to satisfy. So KCL tells us IR. So KCL IR, if we put IR plus IC equals what? So IR is 0.1 and minus 120 degree is equal to minus 0.1 and minus 0.1J, and which is square root of 0.1. Oh no, the square 0.1 times square root of 2, and its angle is minus 135 degree, which is what? Yeah, 1414, which is our I. Okay, so for phasors, KCL also satisfied. And so for the example, let's look at example again. Construct a phasor diagram showing the current and the source voltage. Okay, so let's construct a phasor diagram. It needs to be drawn on this complex plane. So this is RE, this is IN, and to draw it, it's better to use this polar form, IR. Okay, so we need to draw these currents on the so-called phasor diagram. And let me change a different color. So let us draw IR first. So IR is 0.1, angle is minus 180 degree. So we can draw it here. Suppose, okay, this is IR, right? Because this is 180 degree, and suppose the unit is 0.1, and then let us draw IC. So IC is here. It is minus 90 and pointing downward. So this is IC, and I is IR plus IC, right? So if we draw I, we have 0.1414, which is this. I mean, let me use this color. So this is our eye. Okay, so from this Phasor diagram, we can still conclude that I equals IR plus IC. So this is the angle is minus 135 degree. Okay, and also VS, let me use a different color. Also the voltage source, I use black. So VS equals 10 degree minus 90 degree. So VS is here. We have 10. So we have this should be VS, and this is minus 90 degree. Okay. So okay. So we also know that it's a leading circuit, right? Because if we look at the current flowing from the source, the current leads this voltage by 45 degrees. So we say it's a leading circuit. Okay, because the current leads 45 degrees. This is 45 degrees. Okay, so this is the answer of this example one.